Hello. In the earlier two videos, we looked into the Newton method and to find the roots of a given polynomial. In this example, we continue with that. So what I will do next is to go ahead and use the WolframAlpha website, which is, you can see the address here, www.wolframalpha.com, to show you how you can find these roots actually. So y equals, so you just start writing out your cubic polynomial. I believe it was x cubed minus 3x squared minus x plus 2, if I'm not mistaken. I think we started with this one, right? The plus 3 one. Let's first check this one. So if you use this one, let's see if it gives us the correct one. Yes. So you guys can clearly see the roots of minus 1, 1, and 3. So this is the given polynomial, x cubed minus 3x squared minus x plus 3, sorry for that. You can see a plot of this polynomial. You can, and then the three roots are given. In fact, we are also given an alternative form, which was the original form that I started with. So what I did next was to distort this function and f of x, so that function, by just replacing the very last entry by 2. It will just distort the function a little bit. It will still have the same shape, but the roots will no longer be at minus 1, 1, and 3. Do you guys see that? The roots are still close to minus 1, 1, and 3, but it's as if the polynomial has shifted slightly. And as a result, the roots are what they are now. You guys see that? And so obviously this is the free edition of WolframAlpha. There's a lot of websites like this which will do the computations for you. So it's nice to also look at websites like this where to check the shape of the function, the roots of the function, and all that sort. In fact, you can even look into further properties of this function. For instance, this function happens to have some local maximum and minimum. This is something that we will discover next. So this is the local maximum and the local minimum of this function, which is basically this would be the local maximum point, and this will be the local minimum. The reason we call it local and not global is because there are some other points which are, if you look at these points here, they are higher than our local maximum. And when you look at this local minimum, there are some values over here which are, in terms of value on the y-axis, it's lower than this one. But overall, yeah, so those are the local maxima and minima. And in fact, it's not given here, but I can just write next to the function inflection point. And if I said inflection point next to it, it will also give me the inflection points of this polynomial. So it says that this polynomial has an inflection point. Wow, very surprising. At 1, basically, right here. So what it means is up to that point, x equals 1, the polynomial was, the function was looking downward. It was convex down, and then, or concave down, I should say, and then afterwards it became concave up. So this is an inflection point. So pretty good. So the WolframAlpha website is extremely useful for that reason, that I highly recommend a website that you can use. Next, I would like to give you guys another website. It is derivative-calculator.net website, and websites like this are abundant. Again, through website like this, you can do some calculations. Well, obviously we can calculate the derivative of our function. Let's go ahead and start with our function again. I think our function was x cubed minus 3x squared minus x plus 2. Let's first check the derivative of this function, and it's making the computation next, and there you go. So we can clearly see our function here and the derivative of our function. This is another notation for that derivative. Sometimes we show it as a prime, f prime of x, and sometimes d over dx, f of x, and you can clearly see the derivative of our function. So what we can do next is, you guys can see there's a lot of nice stuff. For instance, again, the goal was to find the zeros, the roots. Let's check the roots here in this website, what it comes out as. So the roots are being calculated. Remember, we had 3 roots. Wow, look at that. So the 3 roots are given in algebraic form, right? So in analytical form, you can see the full picture of these roots. That's very, very interesting, actually. You guys see that? And in fact, a further thing is, in the WolframAlpha website, it only gave us the result up to 4 decimal place of accuracy, for instance 3.1149, but in this website it gave us to a larger decimal place of accuracy. For instance, we can as well just check these values. Let's go back to our Excel sheet that we created together. For instance, consider the third iteration. When we started with 1.5, we were able to find the second root up to 4 decimal places of accuracy. Now I select column O, right click it, and I want to format the cells, or alternatively you can go to home and then you can just click on this button, which will increase the decimal places of accuracy for that calculation. For instance, this would be up to 2, 4, 6, 8, 10, 11 decimal places following the decimal sign, right? So let's check, for instance, right, only after 4 steps, only after, I should say, 5 iterations, our calculation came out like this. Let's compare this number with the calculation given to us in that website. So it would be 0.74589, 0.74589. Let's just copy paste it actually. Let's paste it right next to it, Control V, and let's see. Oh, well, actually, it's pretty good already. Let me just increase the decimal place of accuracy. Maybe I need to go a bit more to the side. And there you go. So we have, and I can add more. Let's just go ahead and add more. There you go. So the number was going like this, and look at ours. It is pretty correct. In just 5 iterations, we were able to get the calculation correct up to 1/10 of a billionth. So it is extremely precise, our way of calculation. Interestingly, this is the logic behind calculators as well. Calculators use these iterations because calculators are machines which can make a large amount of calculations in a small period of time. It's not possible to teach machines how to solve an equation, but it's possible to tell the machines to start with an iteration like this and repeatedly use this iteration. Well, in this example, remember that this was supposed to be f of xi divided by f prime of xi. Yeah, with this modification. Yes, so that's the idea behind how precise our calculations is and how useful websites like this are in terms of exploring some stuff about the functions. For instance, here you can not only see the functions, but actually you can zoom in or zoom out into the functions. For instance, here I can clearly see what will be the intercepts of the blue function is the actual function, the red one is the derivative. So let me get rid of it. So you guys can see that the results are very close to -1, 1, and then 3 here. So pretty good. And so on. So yeah, there's also some information about how differentiation works and some additional material. All right, so that will be all for this video. I hope to see you guys in our next video.